All right, let's go back to Jeff.
All right, let's do
any
it.
math questions?
I do have a math question, actually. This is a math question that I have here. This is a kind of this is an equation, and it's this guy. He doesn't know how to solve this. So the equation is 7x squared minus 18x equals 9.
I can take that one.
Is that
Ooh.
okay? Yeah, that's kind of mind-boggling to me too, because I don't quite get that either. So.
Well, we'll solve your problem
Okay,
as well.
good. Yeah, let's do it.
So this is a quadratic equation, and the way that we know that is because like the biggest term is squared. So we want to think about the couple ways that you can solve this. I know you always point out like the 3 ways, right? I always just think about factoring, and then I think about quadratic. What's the other one that you use?
The third way would be undoing, and that would be if we didn't have 2 terms with variables in it.
Right.
Like
okay.
if it were just 7x squared minus 18 equals 9. There were
Right.
not another x there. It would
So
be
we're just going to look
undoing.
at factoring and quadratic then.
Quadratic formula.
Formula. I was going to write equations,
Yeah.
but formula is better. So in order to solve this, we need to first set this equation equal to 0. So I'm going to just bring this over here. And all we're doing is getting everything on one side of the equation. And you'll kind of find because we have those 2 variables, I can't just move everything but that variable to one side. So we're going to think about how we can solve this by factoring. Do you usually teach like a trial and error kind of method, or do you teach like that box method? I'm a little rusty on the box method.
I use the box method, but it does still end up a little bit of a trial and error. The
Right.
other method would be the factoring by parts, where you multiply
Yeah.
A times C. But I don't love to teach that because it's just it's super complicated.
It is.
And it's not necessary.
So I think I always taught it as if you're looking for something like x squared plus, let me think of one that works nicely, 7x plus 21, then we would just do what are the factors of 21 that add up to 7, right? The way I always taught it was what are the factors of A times C that add up to B?
Yeah.
And then setting up a table like that, and I felt like that pretty much always worked.
That ends
if it was factorable.
It's a lot like factoring by parts when you
Okay.
do the A times the C.
I think I just don't know what they're called. So I'm going to first pull out the A, B, and C values. So if you remember, a quadratic equation is written in this form, ax squared plus bx plus c. So I'm going to pull out the values of A, B, and C. And we can just look right here that they're going to be 7, negative 18, and negative 9. So the reason why I'm always going to do this is you're going to find that whether you're going to be able to do this by factoring or by quadratic, you're going to need these values anyway, especially for something like this, where the leading coefficient is not 1, we have a 7 there instead. So I'm going to look for the factors, and this is, again, kind of one of those things that I'm assuming if you're asking this question, you've gone over it a little bit and you just need a little kind of refresher. So hopefully all of this stuff makes sense. So I'm going to look for the factors of A times C that add up to B. And I've pulled these numbers out here. So I like to set up a table. I know some teachers do this a little bit differently, but I'm going to set up over here A times C adds up to B. Right? So A times C in this case, A is 7, C is negative 63. So, oh wait, oops. So A times C is negative 63. So we want 2 numbers that are going to multiply to give me negative 63 and then add up to negative 18. And then this is kind of a guess and check scenario, right? Mm-hmm. So we could think of, you can walk through this and say 1 times 63 the 63 has to be negative because we have a negative sum here. Well, you already know this one's not going to work. We could try 3 times 21. And automatically right there I'm thinking, okay, well, the difference between these two is 18. So which one has to be negative? And if you think, well, the 21 has to be negative because it's the bigger number and we want our sum to be negative, then you are correct. So this would add up to negative 18. And this is where, let me see if I can remember this. So I'm a little bit rusty on this. We're going to set up our table or our box for the box method. And you can feel free to interject if you have like a quick explanation.
Gotcha.
I haven't taught this in a while, so I remember the method, but I don't always have like the best way to explain it just because I haven't worked with a student on this.
I steal all of
in a
those
while.
classes, and I teach them all there at Emily
Yeah.
Griffith, so that's why.
Yeah, so in this box, right, you're going to put your first term, right? 7x squared. And in this box over here, you can't see my cursor, but in this box right here, we're going to put our last term, negative 9. Then what we're going to do, and it doesn't really matter the order, we're going to put these values in here. So I'm going to put a 3 here and a negative 21 here. And then I'm going to take and put an x value here and here. And this should be kind of familiar with what area method or box method or whatever your teacher calls it looks like. Then what we're going to do is we're going to find the greatest common factor, the GCF, of all of these. So what I'm going to do is I'm going to first look here and think, what is the greatest common factor between these two? In this case, both of them have factors of 7, and they both have at least one x in them. And this is also kind of a tricky thing, is that how do you know if you're going to make this positive or negative? Well, in this case, you're going to look at the box closest to the GCF you found. In this case, it's going to be positive. So you know that's a sign. Then we're going to go down here, and we're going to think, what is the GCF of these two? Well, in this case, the greatest common factor is 3. We don't have any x values in this other one. The 3x is positive, so we're going to leave that as positive. We're going to do the exact same process down here. And we're going to look and say, what's the greatest common factor between 7x squared and 3x? We're just going to pull out, like 7 and 3 don't share a factor. So we have an x here. And we're going to do the same thing here. What is the greatest common factor here? So these both have a common factor of 3. Again, this one doesn't have an x. This box right here is negative, so these are our factors. Then I'm going to say, okay, 7x, I'm just going to pull this stuff out. 7x plus 3 times, and then I'm going to pull this one out, x minus 3, and then that all equals 0. So these are the factors right now. So then this comes back to, this was a factorable equation, so this comes back to the 0 product property, in that if I'm solving for x, we could say that if this entire factor was 0, then it doesn't matter what this one that I'm highlighting in blue is, because 0 times anything is going to be 0. So we could either say that 7x plus 3 equals 0, or we can say x minus 3 equals 0. If either one of these factors is 0, again, it doesn't matter what the other factor is, because 0 times anything is 0. And then we can solve for each one of these separately. You're going to have 2 solutions here. So subtract 3, subtract 3, 7x equals negative 3. Then we're just going through and solving, and we get one solution, x equals negative 3 over 7. And we can solve this one, plus 3, x equals 3. So these are our solutions, negative 3/7 and 3. So hopefully that helped. These are kind of a lengthy process. They get a little bit better as you do it a little bit more. And also, we kind of mentioned the kind of guess and check method. I kind of found when I learned this, it was a really tedious process to do this every time. But after you've done it a bunch, you start to recognize some patterns, or you just get a little bit better at doing this whole process, well, the whole process in your head with the table. So it does become a little bit faster. Like just because, and Becca's probably the same way, just because we've done this so much, we're able to like do some of this in our head and skip this and then just check it in the end.
That's very true. These problems don't always take this long. They really don't.
Yeah.
And the more that you practice them and the more that you do them, it just becomes easier. And you also don't need to always write out as much as we do as well. We have that graphic organizer to make it a little bit easier, maybe to visualize what's happening with the numbers, but it's not necessary when showing your work all the time to always have that area model and always have all of that work that we wrote down.
Yeah, we always tell students to write everything down for a couple reasons. One, especially like this process, there's a lot going on. It's really easy to make a mistake, so you can see your mistake, or if you're asking your teacher to check your answer, they can see your mistake and kind of see where you're kind of commonly making the same errors.
Exactly. And it's just a thought process to get used to.
Right.
So